Okie dokie, Smokey, here we go. So the first problem on what we're calling page 8 says find the partial fractions. All right, who remembers the steps we need to go through to find the partial fractions? We need to factor. All right, so we'll do that. We'll factor. So we've got 9x plus 17 over, let's see, if I factor that, it's going to be x plus 3 minus 2. Check that out. Is that right?
Yeah.
So then I know my partial fractions will be something, typically we call it a, really doesn't matter, a over x plus 3 and b over x minus 2. Now we need to get this straight. A and B are not the answer to the question because I set it up this way. But could you have set it up as a over x minus 2 and b over x plus 3? Yes. So then your a and b are going to be switched with mine. The answer is whatever I get for a over this and whatever I get for b over this. And that way we're all going to get the same answer, no matter how we set it up. All right, now what? Clear the fractions. So basically that means multiplying by x plus 3 and x minus 2. I don't care if you show this step or not. You don't have to, because some of you just do this in your head. But what you are doing literally is multiplying by the common denominator so that every denominator cancels. Now, does anybody have a question about that step? Maybe you did it differently, but did you end up with this? You have to. This is what you have to end up with. Okay? Now what? Now we make our equations by looking at the x things as one equation. So that would be 9 equals a plus b. And then the non-x parts, 17 equals negative 2a plus 3b. Everybody got this so far? Now, he says eliminate, because that's what I'm going to do, because that's what I like to do the best. But somehow you solve this, so you could substitute if you like substitution. You could do Kramer's rule, whatever you want to do. But somehow you have to find the a and the b value for this system. So I think I'm just going to multiply the top equation by 2. So 35 equals 5b. I'm getting b equal to 7. And if b equals 7, then a will have to be 2. So the answer is, I got a is 2. I have a over x plus 3. So 2 over x plus 3 plus 7 over x minus 2. And that's going to be your answer no matter how you set up the original problem. Any question about that? All right, now we've got one of these big sketches with asymptotes and all that stuff. All right, so what's the first thing we need to do with this guy? Well, we definitely want to factor if there's a chance that something might cancel out. In this case, there really isn't any factoring to do other than taking out a GCF. So you can do that, it isn't necessary, it's not mandatory, but you can certainly take out a GCF. Is it gonna do you any good? No. So there aren't gonna be any holes in this problem. Because holes only happen when we cancel. Okay. However, it does show me where my vertical asymptote is. Where is my vertical asymptote? At 2. X equals 2. It might make it a little harder for you to see your horizontal asymptote. You might want to look back at the original. Your horizontal asymptote is 3 halves, y equals. My x-intercept is easy to see from here. My x-intercept is going to be at -3. Because what happens if I put in -3 for x? What do I get for y? 0. And that's what an x-intercept is. It's what x value gives you 0. X-intercepts are called zeros. Because they give you 0. They come from the numerator of the fraction. And what about a y-intercept? I'm going to go back to the original. My y-intercept is going to be -9/4. Because how do I find a y-intercept? Plug in 0 for x. No holes, I'm done. So can I see what it looks like? I'm not gonna stop there though, because there's a whole other half of the picture. There it is. Okay, good with that? Next, was your hand going up? All right, now we've got our big linear programming problem. So while I'm putting all this stuff up here, why don't you see if you can fill in the chart? Read the problem, the chart's at the bottom there. Read the problem and see if you can fill in the chart. All right, what have you done so far? Every day, Ted needs a dietary supplement of 4 A's, 11 B's, and 100 C's. Okay, where did the 4, the 11, and the 100 go? Minimum daily need. So 4 A's, 11 B's, and 100 C's. Brand X is 6 cents a pill. So brand X is 6 cents. Now I'm putting 6. If you like to put 0.06, that's fine too. This is cents. 0.06 would be dollars. Y is 8 cents a pill. All right, brand X gives me two A's, 3 B's, and 25 C's. Y gives me 1, 4, and 50. how many pills of each brand should be taken each day in order to satisfy the need most economically? What does that mean? Most economically is just a fancy way of saying cheapest. So we want to minimize the cost, and the cost is 6x plus 8y. Okay, so here we go. Looking at these numbers, I think I can use a scale of 1. Oh, wait, first, before I graph, I gotta write my constraints. What are my equations? 2x plus y greater than or equal to 4. Why is it greater than? A lot of times it's less than. Why is it greater than? Because 4 is the minimum. I have to have at least 4 5-minutes. Okay, and then 3x plus 4y is greater than or equal to 11. And 25x plus 50y greater than or equal to 100. Does that make sense to everybody? So now I'm going to graph them. So right here. I'm going to use a scale of 1. Actually, yeah, I've got it kind of spread out there for you on the paper. So if x is 0, y is 4. If y is 0, x is 2. So there's my first line. And my board's already a disaster, so I'm not shading. But where would you be shading? Where are you shading? All of this, right? Out here. All that.
Well, why do we need to shade?
Because it's an inequality.
Wow, how does the shading help us?
The answer is going to be the overlap of all the shading. If you haven't shaded, you won't know where the overlap is. Okay. Now, don't be alarmed if they're not whole numbers. It's okay. Graph them anyway. All right? So, if x is 0, y is going to be 11 fourths, which is 2.75, I think. And if y is 0, x is 11 thirds, which is 3 2/3. Don't be alarmed. It's enough. Okay. Fractions. Connect them. And shaded where? Above. So now I'm looking at the area right here. All this. And now this guy. Well, if x is 0, y is 2. And if y is 0, x is 4. And that one is also shaded above, right? So if I look at, on your paper, everything that is shaded above blue, above red, and above green isn't what's shaded, outlined by this black line. Remember, I'm in quadrant 1. X and Y are positive numbers. I can't have negative pills. So I'm in quadrant 1, so I'm bounded by these two lines, and then this. Does that make sense to everybody? So there are 1, 2, 3, 4 corner points, 4 corner points. Angles. This one I know, 0, 4. This one I know, 4, 0. These two I don't know. So I need to figure them out. problem. I have to figure these out. Takes forever. This point right here is the intersection of my blue line and my red line. So this point right here is the intersection of 2x plus y equals 4 and 3x plus 4y equals 11. That's my blue and my red line, which are coming together right there at that point. So what do I have to do? Substitute, eliminate, Kramer's rule, inverse, whatever you want to do. I'm gonna eliminate, but you can do whatever you want. You could substitute in this one relatively easily. But somehow, you gotta solve this system to find this point. So I think I'll multiply the top one by -4. So I got x equal to 1. And with x equals 1, I'll plug that back in. And it looks like y is going to equal 2. So there's another point. Remember, I have 4 altogether. Now I need this one. I'm going to have to repeat the process. But this one's going to be my red and my green. So 3x plus 4y is 11. And 25x and 50y is 100. Now, we haven't talked about this before, but I just want to throw another option at you. Did you notice that everything in that equation is divisible by 25? So if you wanted, you could reduce that equation to x plus 2y equals 4. And that might make your work a little bit easier. I'm not trying to confuse you. I'm just saying that's an option. Since everything there is divisible, you can go ahead and divide. You can solve it like this, but these numbers are kind of not fine. You shouldn't need my help on this. You should be cranking this out on your own. I got x equals 3. My picture's off. Doesn't matter. If x is 3, then it looks like y is, wait, is x 3?
I got X. Yeah.
Okay, and then y is a half? Yeah, x is 3, right. And we're still not done, because we haven't answered the question yet. How are we gonna answer the question? What do we need to do now?
Multiply, find the smallest number.
For the cost, right? So we're gonna take 6 times every x and 8 times every y. Well, I can do that one in my head. That's gonna be 32 cents if I take no a's and 4 b's. And if I take 4 a's and no b's, that's 24 cents. So there's the cheapest option so far. What if I do 1 of these and 2 of these? 1, 2. Is that 22 cents? What if I do 3 of these and a half of those? Is that also 22? So that's good news. That means I have an option, right? Now, if this is me I'm probably gonna go with this so that I don't have to mess around taking half a pill. But I could, I mean, you can cut them in half, and so if this is what you wanted. So what are we gonna tell this guy? You're gonna need 1A pill and 2B pills, or 3 A's and a half a B, and it's gonna cost you 22 cents a day. Okay, that ultimately is the answer, some kind of, this is what you need to do sentence. Got it? There's a lot there, that's a biggie, that's a biggie. Okay. Take a quick look, we got a few minutes before lunch. Not page 9, because we're gonna start page 9 and cram through the whole thing. So not page 9, but any other page in the packet. Some of them aren't numbered, but we'll figure out. I thought I numbered them all, but I didn't. So tell me what in that packet you need to do, other than the very last page.
3, the bottom one.
Which one?
3 on the bottom.
On page 3,
Yeah.
page 3, the bottom graph.
Like this.
You're at page 3.
Or back, no, back of page 2, sorry, I thought it was 3.
Back on page 2. Page 2. The bottom problem, where it says Kramer's rule,
No, the back of that page.
back of that page.
Yeah.
Which one am I doing?
The one on the bottom.
Okay, I don't know what you're talking about.
This one.
Okay, I'm not doing all those. Take one.
Okay, let's do C.
All right, so problem C. I'll write the problem down in case you can't figure out what we're talking about here. We have, well, I'm not even gonna write it down because A is a 2 by 2 and C is a 3 by 3, and the problem says multiply them. Can they be multiplied? No. So I'm not gonna write down all the problems. That was a multiplication problem. Now, she wants to do a multiplication problem, so I'll just make one up that does multiply. So I could take a 2 by 2 and I can multiply it by whatever I want as long as what? It has 2 rows, right? So I can I'll make it a 2 by 4. And that'll multiply, right? And my answer will be another 2 by 4. So it's gonna have 2 rows and 4 columns. Now, you don't need to put these boxes in. I just want you to get a sense for those are the numbers you need to find. Right? And when we multiply, we do it row by column. Always row by column. So it's easy. The numbers in the row are 1 and 2. The numbers in the column are 1 and 6. Multiply them and add them. So what is the number that goes right here? 13. That's row 1, column 1. Row 1, column 1. So now if I move over here, I'm still in row 1, but now I'm in column 2. So that entry will be 2. Still in row 1, but now column 3. So that one is -1. And one more time, still in row 1, but now column 4. Another -1. And then we will do exactly the same thing, except we'll be using row 2. So we'll have our 3 and our 4 times, once for each column. So the first column, 1 6. See how systematic it is? It's like a system. So it looks like that bottom row is going to be 27, 4, -3, and 1. Did I get those right? Anybody else do it?
Yeah, you
Anybody
got those
besides
right.
me?
You got them right, Mr. Gordon.
Yeah.
Thank you, I appreciate that.
You're welcome.
All right, one more quickie, and then it will be time to go to lunch. When you get back, we're gonna get back your quizzes, so you can see what kind of mistakes you made on those. Everybody except Max. Okay, so one more quickly, what do we need to do? Just to make sure. What's the answer to that determinant?
Negative 28.
Negative 28.
Negative 28, because it's negative 10 minus 18. Negative 28. What's the answer to this one?
No, 30. It's 30. It's 30.
It's 30, because it's 0 minus
And that's a positive.
30. Guys, you want to be careful with those little determinants, because you can do them in your head, but if you mess it up, you're going to miss Kramer's rule, you're going to miss the inverse method, you're going to miss a lot of things. All right, I want you back at 49. Back at 49.
No, but.
You need to step out, Kara, and do something like get